So when we're solving multiplication equations, like we just talked about 3x equals 15, 3 is the coefficient, x is being multiplied by 3. With our algebra tiles, we divided the algebra tiles into 3 groups because there were 3 x tiles, and then we made equal amounts of unit tiles to match up with them, right? And that's how we got our solution. Well, if we didn't use algebra tiles, what could we really just do? What could we do that we would still keep it balanced? Remember, that's always our goal, keep it balanced. So if we didn't use algebra tiles and we had to solve, I'm just going to do it up here. If I had to solve 3x equals 15 without algebra tiles, what would I do? We know that the answer is 5. That's, yeah, we already know that. But what can I do to actually get 5 without algebra tiles? Kaden? You take 15 divided by 3, but if you divide that side by 3, what else do you have to do? You have to divide the other side by 3 also, because you're going to do this. Whatever you do on one side, you're going to do on the other one, or the teeter-totter's not balanced anymore. So we would divide those x tiles into 3 equal groups. We would divide those 15 unit tiles into 3 equal groups, and we would find out that our equal groups have 5 unit tiles, right? X equals 5. Okay, well, what about when we have the situation that we are multiplying the coefficient? The multiplier is not a nice number like 3. What if we couldn't really put an x tile on the table, that many x tiles on the table for what the equation says? So here's what we're going to do. To solve for x when it is being multiplied by a fraction, we will multiply both sides of the equation, because remember, whatever we do to one, we got to do to the other side, by the reciprocal, which we just talked about before we started these notes, by the reciprocal of that fraction. Because when we were using algebra tiles, our goal was to get the x tiles kind of like by themselves. They had to each be lined up with something, and they each had to be lined up with the same amount of somethings. So we needed one x tile to equal something. Well, in 3x equals 15, one x tile equals what? In 3x equals 15, one x tile equals what? No. In 3x equals 15, one x tile equals 5. So we need one of it. So, one sounds kind of familiar when I use the word reciprocal. Okay, let's look at this equation. 4/3 x equals 12. If I told you right now, I said, go get your bag of algebra tiles and model this on your desk for me, could you? 4/3 x. What mixed number is 4/3, by the way? Sylvia? 1 and 1/3. So you would need 1 and 1/3 x tiles. Is that possible? No. So sometimes algebra tiles don't work very well for modeling some of our equations, and this is one of those situations. You couldn't make this happen on your desk for me, could you, with the algebra tiles? So what we're going to do is we're going to do what I just set up here. We're going to multiply both sides of the equation by the reciprocal of the coefficient. So in number 1, what's our coefficient? Okay, write it on your paper then. If you're not going to talk to me, then write it down. The coefficient is, fill it in. The coefficient is, in 4/3 x equals 12. What is the coefficient? Remember, the coefficient is what the variable is being multiplied by. Okay, now who wants to share? Come on. I'm not worried about how much homework time you get. 10? 4/3, yeah. X is being multiplied by 4/3. That's the coefficient. So now, if we are going to solve this, we need to multiply by its reciprocal. So we're going to fill in these blanks and say, well, this reciprocal of 4/3 is what? What is it, class? 3/4. Flip it over. So that's the first decision you gotta make. What is the variable being multiplied by? And then, if it's a fraction like it is in this one, we're going to multiply by the reciprocal of that fraction. So let's start it right here. We're going to do 3/4 the reciprocal, multiply both sides of the equation by the reciprocal. So notice what I did. This matches this. I'm just introducing multiplying it times 3/4. But if I do that on that side, guess what? I have to do it on the other side. That 12 is also going to get multiplied times 3/4. So 3/4 times the 12, it gets its. So basically what we're doing, the circle parts match exactly what it was. And I am now multiplying both sides by 3/4, doing the same thing on both sides. Everything should be all right. Well, tell me, people, what happens when we take 3/4 times 4/3? What do we get? 12/12, which is 1. So you know what? Don't waste your time saying 12/12 or writing it. We're just going to write 1 because we know that when you take a number times its reciprocal, you will always get. You will always get 1. Thank you. Yes. So we are going to say, you know what? This is 1x. This is now 1x. And over here, oh, well, I need to make this into a fraction. Okay, and we're not going to make it into, okay, let's just do that right here. We're not going to make it into a fraction so that we can flip it. We're not going to flip it. We're just going to make it into a fraction so we can multiply it. So over here we end up with our 1x. Can't really do anything with that at the moment. What's 3 times 12? 36. Upstairs, 3 times 12 is 36. What's 4 times 1 downstairs, class? Oh, Caden's not the only one in this class. 4 times 1 is 4. So now we're going to end up with 1x equals whatever 36 divided by 4 is. You go figure that out. Wait, you got it? What is it? 9. So if we really could have done this with algebra tiles, every algebra tile would have lined up with 9 unit tiles. Oh, we really couldn't do it. It was kind of hard. I wouldn't let you snap those in pieces, so, right? So, we're going to clean this up. Yeah, you could, but you might get in trouble. So, we're going to clean this up. Anybody know what can be left out of there? If there's only 1x, what's that the same as then? X. If we have a 1x, that's the same as x. We will not see it written with a 1 in front of it. We can clean it up, I call it. 1x is the same as x. So that is our solution. Okay? So let's check our answer now. X equals 9. That's our, let's put that right here. This is our solution. X equals 9 is our solution. So we are going to substitute it. Now we're not solving. Okay, keep this straight. Keep this straight. When we are solving, when we're trying to figure out what the variable is, then we have to do the same thing on both sides. When we're not solving, when we're checking, we're substituting in and we're just evaluating. We're just saying, okay, just do the math. Don't worry about the balance scale, okay? Until the end. So 4/3 times what? 9. We said x is 9 equals 12. Well, we have to take a fraction times that 9. What should we do with that 9? Put a 1 under it, okay. Multiply across the top. What's 4 times 9? 36. 3 times 1 class is 3. 36 over 3 means 36 divided by 3. I get 12, what do you get? Yeah. So I say 36 over 3 gets replaced by 12. I bring down my equal sign. I bring down the 12 on the other side because there wasn't anything to do. Does it check? We end up with a true statement. It checks. So we're going to not only solve it, but even check. Okay? Questions? Everybody's got this? Written down when I'm on the front? Okay, fill in the blanks right here. Fill in those blanks for me on your notes. Reciprocal is, or the coefficient is, its reciprocal is. Put that down. Okay. Hannah, would you tell me what the coefficient is, please? 1 what? 1/4, okay. And Derek, would you tell me what its reciprocal is?
4 over 1.
4 over 1, okay. Anybody want to disagree, challenge, convince us otherwise? Okay. Well, then that means what are we going to do? If the coefficient is 1/4 and its reciprocal is 4 over 1, what are we going to do? Nowhere near. Divide. Well, divide is kind of handy when the coefficient is not a fraction. But when the coefficient is a fraction, it's not so friendly. Harley? Multiply what? Read both sides of the equation by the reciprocal, which is 4 over 1. So we're going to say 4 over 1 times this side, 1/4 A, 4 over 1 times the other side, which is 3. Okay, folks, what happens again when you take a fraction times its reciprocal? You get 1. We will always get 1 when we're multiplying a number times its reciprocal, whether it's a fraction or a whole number to start with. So that side becomes 1A. The other side, what are we going to do over there? What should we do? Yeah? Put a 1 under that 3. So 4 times 3 is, across the top, 12. 1 times 1 downstairs is 1. Do you think that's how we'll see the answer in an answer bank? No. How do you think they would clean it up? Make it just 12 on the right side. Okay, they get rid of that under that 1 downstairs because dividing by 1, would that still be 12? Yeah, so we could clean that side up to be 12. How about the other side? Can we clean the other side up? Or would we clean it up to, Sylvia? To just A. Yeah, we just need it to be A. We don't have to worry about that 1. Now, that's the only number that gets to be ditched like that, though. That's the only coefficient that gets to be ditched. If it was a -1, no. We can't ditch it then. If it was still a 2, no, we can't ditch it then. But this is a positive 1. So we're going to check our answer. We think the answer is A equals 12. So we're going to check ourselves out. So we have 1/4. We're not solving, we are what? Checking, and in checking we do what? S sub substitute. So we're substituting in the A value that we got. Any suggestions for what we should do with that A value? Do what? What should we do with that 12 we just put in so that we can evaluate? Put it over 1. Okay, so 1/4 times 12 over 1 makes it a whole lot easier to do the multiplying, doesn't it? 1 times 12 upstairs, class, is 12. 4 times 1 downstairs is 4. Oh, I didn't allow myself enough room here. Okay, well then I'll just move over here. Because I'm not done yet. I got a 12 over 4. What's that? What's 12 divided by 4? 3. Okay. So the 12 divided by 4 becomes 3. We already have an equals 3. It checks, doesn't it? We got a good answer. Okay. Anybody want to ask any questions before we go on and challenge yourself with this tough one? Okay. Tell me something about the coefficient this time. It's a small number? It's a whole number. Okay, it's a whole number. So how is that different from the last two we just did? They were fractions. So now the variable is being multiplied by a whole number. Do you think we have to worry about reciprocal in this problem? Why not? Because it's not a fraction. So when the coefficient's a fraction, then we're going to deal with reciprocal. When it's not, what do you think we could do? This would be a good algebra tile on, wouldn't it? What could we do in this situation? Okay? But if we divide 25 by 5, what else has to be divided by 5? Remember, whatever you do on one side, you got to do on the other. You're going to divide both sides by 5. In other words, these 5 variable tiles have to be separated into 5 groups, don't they? 1 in each group. So we have to divide that side by 5. We have to divide this side by 5. And we are going to get M. We would have a 1M tile by itself, wouldn't we? And what would 25 divided by 5 be? How much would be in each group? 5. Did we do check problems for those two? Uh-huh. Don't you remember? Uh-huh. We did. Check. Let's just go over here and do it. Check. We have M equals 5. So we're going to substitute 5 in for the M. It's 5 times M, so it's going to be 5 times 5. Five times 5 is 25. Bring down our equals, bring down our 25. True or false statement? True. True. Okay. So when the coefficient is not a fraction, don't work so hard, huh? Make it easier, right? Okay. Questions, anyone? Okay, well, chances are you need some loose leaves. You might as well get it out.